All right, so we're diving in here to some transformations of functions from parent equations. A lot going on here, so bear with me. We're going to look for the general form. The general form is what I have listed here. So this stretch factor here of a, and then we got this h and the k, which will work as our locator point. And so this is f of x, but it's transformed a bit. So we're going to use this as our basis to always kind of come back to when we're using function notation. And so our goal will be to get to this form, and then we can reflect, then stretch, then shift the graph. And I'm going to just kind of follow these steps to go through that. Figure out the equation, put in general form. Find the locator point hk, and then use the stretch factor to figure out where the graph goes, whether it's up and down, by what factor. And so let's just work with an example. So if we have f of x equals x squared, and the question asks to graph 2 times f of x plus 5 minus 2, what do I do? Well, I got to figure out what this becomes. So 2 times f of x plus 5 minus 2, what does that equal? Well, that equals 2 times f of x, which is x squared, but x is replaced with x plus 5. Square that, and then subtract 2. Okay, so now I've got step 1, find the equation, put in general form. Here's the form that I want. And I can identify from that what a is, which is the number out front, 2. H is going to be the opposites, because there's minus h, so this is going to be the opposite of that, so that's negative 5. And k is going to be, what it is there, negative 2. All right, and from here, I can graph this. So you need to know something about parent graphs. You need to know what a parabola looks like and be familiar with it before you do this. But so the locator point here is negative 5, negative 2. So I'm going to go negative 2, 3, 4, 5, negative 2. Put a dot there. That's where my first one goes. And then from there, now that I've got my home base, so to speak, I can use my stretch factor to figure out, is it opening up? Is it opening down? What's happening? What's positive? So it's opening up. And so normally there's a pattern with quadratics that have just a leading coefficient of 1. The pattern is that it goes over 1, over 1, up 3, up 5, right? So instead of going up 1, up 3, up 5, it goes double that because we got 2 times that. So instead of going over 1, up 1 for this next point, it's over 1, up 2. And then instead of going over 1, up 3, I go over 1, up double that. So instead of going up 3, I'd go up 6. So 1, 2, 3, 4, 5, 6. And I have the same exact thing on the other side. Now, obviously, if you're using a calculator, you could graph this and look at the table and figure out what it looks like. And in fact, you probably should do that to double check the work, right, if you're allowed to. But in my class, you're not allowed to use a calculator all the time, and you're asked to graph these without it. So that's exactly how you would graph that. You could keep going, obviously. But again, you need to go back to, you need to know how to graph this without a calculator from the get-go, and there's some patterns there. Let's look at another example. G of x equals 1 over x. So for that one, I need to find the parent function is 1 over x, the general form, sorry. So 2 times f of x, which is going to be f of negative x plus 2. So that's going to be 2 times 1 over negative x plus 2 plus 3. And so there's some tricks here. There's some tricks to figuring this part out. What's going to be helpful is if my a term, it always ends up top. And that's going to really help me out. And that includes any of the negative signs that may have occurred inside here. So what I'm going to do is I guess I'll do this in 2 steps. So that equals, so I'll put the 2 up top first. I've got my negative x plus 2 plus 3. And in order to get the proper locator point and to get rid of this negative sign, if I just have that negative sign move to the top, if I factor out a negative from the bottom and have it go to the top, I can have the negative 2 there. But then in order to make sure that this is the same, I would have to have this happen. So I factored out a negative 1 down here so that it's really like there's a negative 1 multiplied times it, right? So I'm multiplying times negative 1 over negative 1. And that would cause this to happen. So still plus 3. That's just on this part, all right? So I didn't change the value here. This is exactly what your general form would be. And that helps us out because our A is going to be negative 2. Our H is going to be positive 2. And our K is going to be positive 3. Now, 1 over x, there's going to be some asymptotes there. So normally the asymptotes are at x equals 0, which is the y-axis, and y equals 0, which is the x-axis. But those are all shifted over. So our locator point now, is 2, 3, 2, 3, 1, 2, and then 1, 2, 3. That's our locator point right there, but that's not a point on the graph. That's actually the intersection. It's the intersection of both of the asymptotes, the horizontal asymptote and the vertical asymptote. So I'm going to put these little dotted lines there to represent the asymptotes. There's that, and then another one goes at 2. So dotted lines go there. And that's the intersection point of our asymptotes. All right, so we're really, really, really close. And now I need to figure out what my graph looks like from there. My stretch factor is negative 2. Something weird's going to happen. So normally the graph looks like this, kind of like that, right? But it's going to be reflected over, it's going to be reversed, so it's actually going to look exact opposite. It's going to look like this. So there's going to be kind of over here. Here's an asymptote, so I know it's going to go this way, and it's going to come up, and it's going this way. I just don't know exactly where, and I want to graph at least a point or two on here to make sure that my graph is a little bit more accurate. So in order to figure out some of these points over here, what I'm going to do is I'm going to create a quick little XY table. And I'm going to start plugging in some points. So I think that there'll probably be a point around here. Let's try what happens when x is 0. So let's examine this a little closer. When x is 0 here, I have negative 2 divided by 0 minus 2. So that's negative 2 divided by negative 2. So that's positive 1, right? Negative by negative is a positive 1 plus 3. So that's 4, right? So I know I have the point 0, 4 on the graph. So 0, 1, 2, 3, 4, which I was on the right path there. And then what happens when x is 1? So what if I go 1 over here? So what if x is 1? So then I have negative 2 over 1 minus 2. So 1 minus 2 would be negative 1. That'd be negative 2 divided by negative 1, which would be positive 1, plus 3. Positive 1 plus 3, so that's 4. But I don't think that's right. Did I do that? I must have done, oh no, I'm sorry, that's positive 2. I messed up. I knew that seemed too weird. That wouldn't be in a line there, right? Negative 2 over negative 1 is positive 2. Sorry about that. Negative 2 divided by positive 1, or negative 2 divided by negative 1 is positive 1 plus positive 2 plus 3 is 5. Oh my gosh, I just got tongue-tied. Man. So okay, that's that point there. 1, 5. 1, 2, 3, 4, 5. In my head it makes sense when I'm trying to explain it. Anyway, when I go to 2, what happens? So 2 minus 2. Well, that's a bad number, right? That was one of our horizontal asymptotes. That's not going to work. What happens when x is 3? So then when x is 3, 3 minus 2 is 1. So negative 2 over positive 1 is negative 2 plus 3 is 1. So we got 1, 2, 3, 1. That point is on there. And then we got the point 4. And 4 minus 2 is 2. So that's negative... What's that going to be? 2. So it's going to be negative 1 plus 3. That's going to be 2 right here. So just using the table, I can figure out these points as well. Right? And I'm kind of just saving space here by showing you in a quick little table there. But that is my graph. That is how I would transform that function. I have to know something about the parent, and then I have to apply all that. So get it in this form first, and then figure out your locator point and analyze the A. If you don't know exactly where the point should go, start using a table of values. I could have done the same thing over here to figure out the rest of them, just knowing that I can just plug in the numbers. It takes a little bit longer, but if you don't know immediately where they should go, that's one way to do it. Good luck.